In this project, I built a neural network using PyTorch to classify images from the CIFAR100 dataset. I tried different combinations of parameters to find what gives the best accuracy. And to do this, I import some necessary libraries like import OS, import pickle, import torch, torch.optim, torch.nn functional, import time, pandas, and tqdm for building, training, tracking, and saving the model's progress. And to download the CIFAR100 dataset directly in the Google Colab, I use the link directly and set the device configuration for GPU or CPU. Device equals to torch device, that is CUDA if CUDA is available, else it will use the CPU. And I downloaded the CIFAR100 dataset, which has 60,032 by 32 color images across 100 classes. And to train the dataset, I divided it by 255. Actually, that is for the pixel values ranges from 0 to 255. I divided by 255 to normalize them between 0 to 1, which helps the model train faster and more stable. And I built a custom MLP, multi-layer perceptron model, using 2 hidden layers. And for to do that, I use the batch normalizations. It speeds up training and makes it more stable by normalizing layer inputs. I also use dropouts to prevent overfitting by randomly tuning of neurons during training, and used ReLU and sigmoid, and ReLU is faster and helps avoid vanishing gradients, and sigmoid is used for binary style activations. Also, I used softmax or sigmoid in output layer, and the softmax is used when we want single output like cross entropy, and sigmoid is used when with MSE when treating it as a multi-level one hot problem. Also, I use some learning rate in hyperparameter grid search, that is 0.003 for Adam optimizer and ADA grid, and it is the step size the optimizer takes while minimizing loss. If it's too high, training is unstable; too low, the training is slow. And also I used weight decay for Adam optimizer. It's a regularization technique that discourages large weight to help prevent overfitting. And Adam adjusted learning rate per parameter, good for complex model, and ADA grade is better when features have different frequencies. Also, I used 20 epochs for the training purpose, because more than that it will slow down the process and hamper the final output. So I use the 20 epoch for the process, for this process. And I use two types of loss function, that is cross entropy and MAC, mean squared error. And cross entropy is based for classification tasks where labels are integers, and MAC works when we use one hot encoded labels. It transforms a label like 3 into a vector like 0, 0, 1, 0, which is needed for MAC. Also, I used two different types of batch size, that is 1000 and 2000. And larger batch makes training faster with more stable gradient but need more memory. And For the 20 epoch, actually, I train 20 epoch. Each loop does forward pass, prediction, loss calculation, back propagation, and optimizer step, that is weight update. And to evaluate the test, check how well the model generalizes to new or unseen data. In the hyperparameter grid search, I tried 32 different configuration of parameters to find the best combination, and it helps systematically test multiple setups instead of guessing. I save result like uh, accuracy, time, and errors into CSV files after every configuration. That helps track performance and avoid returns. From this experiment, ReLU, Adam, and cross entropy usually gives better accuracy. Softmax works best with cross entropy, and sigmoid with MAC. Dropout and batch norm helps prevent overfitting. On encoding is only needed with the MAC loss. And the maximum output I get from this is 34.75%. This is the 34.75%, and it's for hidden size like 240, hidden activation ReLU, and output activation, that is softmax. Loss is MAC, optimizer ADA grade, and best size is 2000. That is all for this program, and thank you for watching.